So hello there and welcome back. In this video, we are going to solve our very first problem on the graph data structure. So the problem that we have is find if path exists. So the statement says like given edges and the integers and source and destination, return true if there is a valid path from source to destination or false otherwise. So let us take an example to understand what the problem really is. So we will be given number of nodes, so that is n. So in this example, we are given three nodes, 0, 1, and 2. And then we are given the edges between those nodes. So it says node 0 is connected to node 1 is connected to node 2, and node 2 is connected to node 0. And then it says that the source, the starting point is 0 and the destination is 2. So it is asking whether we can start from source, that is 0, and reach the destination, that is 2. Is it possible? Of course it is possible, and in fact there are two ways. We can reach from 0 to 2 directly, or we can use this path 0 to 1 and 1 to 2. Whatever the case is, the answer is true. Yes, we can reach 2 starting from 0 in the following graph. Let us consider an example where the answer is output is false. So in this example, we are given number of nodes is equal to 6. So we have 0, 1, 2, 3, 4, 5 nodes, and the edges given are the edges are 0 is connected to 1, 0 is connected to 2, 3 is connected to 5, 5 is connected to 4, and 4 is connected to 3. So we have the following graph. Now it says that we have the source starting at 0. So this is the source this time. And we need to find if we can reach the destination, right? And the destination for this example is 5. So can we reach 5? The answer is no, because there is no path that connects 0 to 5, or like there is no possible case clearly to reach 5 from 0 in the following graph. There is no path. So therefore we return false. So how are we doing this? So the basic idea is you just do a simple depth first search or breadth first search, doesn't matter. You do a traversal technique actually. You do the traversal and starting with source. You traverse starting with source. And while you are traversing, uh, just keep a note of what are the nodes you are visiting. The moment you are visiting a node which is equal to destination, you just break everything what you are doing and you return true. And if the traversal is over and there is no triggering, this condition is never met in the entire traversal. So at the end of it, you want to return false because you traverse the entire graph starting with source and you never found the destination on the entire traversal that you took, that uh, you performed on the graph. So now let's quickly shift to the editor and see how we actually code this solution for this problem. So I have everything set for the example one that we saw earlier, and we are going to program and test that on the editor. So I'm going to create a function valid path that will take argument all the above parameters, that is number of nodes, edges, source, and destination. Now before I do anything, I'd add a base condition that if source is equal to destination, so just return true because we are already at the destination. So that makes sense. So we just need to traverse the graph. We can use breadth first search or depth first search. So I'm going to use breadth first search. So first of all, I'll define a set which will be empty for now, which will contain visited nodes. After that, I need to first create my adjacency list, right? I'll name it at ADJ, and this will be nothing but a list of empty lists for n elements, that is n number of nodes. So I'll quickly fill this adj list, that is I'll iterate over the edges and I'll add the adjacency to each of the nodes on my adjacency list. So um, when the edge is between uh, 0 and 1, let's say, I'll have to add uh, 1 to 0 and also 0 to 1. So that is what I'm doing here. So our adjacency list is ready, and we will be using this to traverse the neighbors. So this is nothing but our adjacency list neighbors. Now I'll create a queue, and the only element that I'm going to add is source. And just like the breadth first search, we'll get into a while loop. While the length of queue is not equal to 0, we want this loop to keep repeating itself. And the first thing in the loop, we want to pop out the element at the front. So pop 0, we want to pop out the element from the front of the queue, and that will be v. We will check if the vertex v is in the visited. So if v is in visited, what we want to do is we just want to simply continue with our queue. But if it is not, we are going to add it to the visited, because now we have visited it. And now I need to iterate over all the neighbors of the vertex v and add them to queue if they are not visited. So to do that, I'll be using the adj list that we created. So for neighbors in adj v, first of all, if the neighbor is equal to the destination, right, we want to quickly return true. We have found somehow found a path to reach the destination. We want to return true and end everything. If not, we want to check if this neighbor is in visited. So if it is not, so if neighbor is not in visited, this is the first time we are reaching this node, we want to add it to the queue and continue the breadth first search on it. This is how the BFS works. So simple BFS algorithm. And at the bottom of it, outside while loop, I want to return false. So if we never reached the destination, that means there is no possible path. So let's test our function. So I'll print valid path and pass all the arguments that I have defined on the top to this function. Here I do need to correct the spelling of edges. So, and now I'll simply run the program and see what the output is. It should be true, and yes, it is true. So it's working properly. And just to test it, what we are going to do is make the number of nodes equal to 4, and there is no node reaching the node equal to 3, right? So I'm going to set destination as 3, and the output should be false because there is no edge from 0 to 3. In fact, there is no edge connecting 3, so the output should be false. And yes, it's false, so it's working pretty good. And we are done with the solution. We have programmed the solution for this problem: find if path exists. This problem was a relatively simple problem. Next up, we will be looking at a slight variant of this problem, and that problem on the first glance does not look like if it is a graph problem at all, but that is what we have next up. See you there.